Hello everyone and welcome to the show. It is that time of the year where we start revising, and remember, it's never too early to start revision. Grade 12, today's lesson is all about you, and it's all about functions and inverses, and as I said, we're going to revise those important concepts that you need for your final exams. So let's talk a little bit about revision first before we start talking about the topics that you need for this section and the concepts that you need for this section. Just a little bit of advice. Remember that you should, in your revision, really concentrate and prioritize the sections that you are weak on. Now, I know it's very, very tempting to just stick to the work that you're very good at, the concepts that you always get right, but remember, in the final exam, you're going to be tested on everything you know, so it doesn't make sense to only concentrate on the sections you're good at, rather focus on your weak subjects, okay? So really what I want to convey to you is that you need to concentrate on the sections that you are not too confident in, because you are more likely to then have a much better overall understanding of all the work that you're going to be examined on. Now, some of you may not know which sections you are weak at, and if that is indeed the case, then please go and talk to your teachers. They will have a better understanding of which sections you are weak at. But also, if you just look back at your tests and exams, it's a very good indication where you got fewer marks or maybe even no marks. That's an indication of a topic that you really need to work on, okay? So remember, we are really aiming to revise everything for the final exam, but you need to spend more time on the sections that you don't understand or the ones that you know less well. Now, when it comes to the CAPS breakdown for your exams, this is how it works. Your functions and your graphs, which is what we're looking at now, excluding cubic graphs. Right? This is roughly about 35 marks in the final exam, and that accounts for roughly 23% of your maths paper 1. Quite a substantial percentage that. So it is a topic that does need you to focus and to really concentrate on understanding some of those basic concepts. And that's what we're going to be doing in today's lesson. So this is a good revision for those of you who are not too sure with functions and inverses. And considering that it's over 23% or just over 23%, it is a very important subject to concentrate on. Now, the sections that you need to be able to do for your final exams, you need to be able to sketch and interpret your linear graphs, straight line graphs. Remember, those are y is equal to mx plus c. Your quadratic functions defined by y is equal to ax squared plus bx plus c. Obviously, your hyperbole, and that's including your vertical and horizontal shifts, exponential graphs as well, including the shifts, and your logarithmic graphs. Often these two, the exponential and log graphs, will be tested together, where we look at inverses. This is obviously the log graphs, and the inverses is obviously a topic that you learn in grade 12 for the first time. Now, with all of these graphs, the linear, quadratic, hyperbola, exponential, log graphs, all of those, you need to also be able to understand how to interpret them when they're all drawn in one diagram. All right? Now, a reminder about inverses. If you are given some invertible function f of x, we determine the inverse f inverse x. Remember, this is not a power. This indicates to me that I am dealing with an inverse, so it's not a power. Okay, so f inverse x, in order to find the inverse, you start by replacing every x with y and your y's with x. You then make y the subject of the equation and express the new equation in function notation, or as they have asked you to leave it in your exams. Now, if we represent and if we draw the functions f and its inverse function, the two graphs will reflect about the line y is equal to x. Importantly, with inverses, the domain of your function, the original function that is, will then be equal to the range of the inverse. And similarly, the range of the original function will be equal to the domain of the inverse. So those two things swap around as well. okay? The inverse function of a straight line graph will also be a straight line, except for in the case of vertical and horizontal lines. The inverse of a parabola is not a function. However, we can limit the domain of the parabola so that the inverse of the parabola is a function. And you guys would have seen this when you're dealing with many-to-one functions. It's important to restrict the domain of your original function so that you get an inverse graph that is also a function. So that's basically what we're saying there. And then lastly, the inverse of the exponential function is the logarithmic function. Okay. So that's going to take us straight into our first question for today, and this comes from your DBE Maths Paper 1, November 2014, question 5. So while you're revising, remember that it's very important to go over past exam papers. Go back as far as you can get your hands on, but usually the last two to 3 years is a good indication. So these questions come straight from those exam papers. I'm going to give you a chance just to look at the question. So I'm not going to give you really much time to do the question. I really want you to just be familiar with this question. However, as I said, it is in those past exam papers. So get your hands on those exam papers that are available online, and you can then have the entire question in front of you. The memos are also available online so that you can go back and check your solutions as we go through today's lesson. So really what I want to do is I'm just going to give you guys 2 minutes just to have a look at this question and understand what's going on, and then we'll go through it in detail. Or maybe during this time what you can do is locate this exam paper if you've got a past exam paper book. All right, so have a look at this question. We'll give you 2 minutes. Okay, everyone, I hope that you had time to just think about this question. As I said, the point is not to do the question in 2 minutes. That's not possible. The point is really just to familiarize yourself with what the question is asking. And this is from a past paper, so if you can find the past paper, you will be able to have full access to this question. Okay, so let's read the question. That's always a good place to start when you're given an exam question. We are given that f of x is equal to log x base a, where a is greater than 0. As is always the case, your base needs to always be positive. You are given a point S with the coordinates x is 1/3 and y is -1, and that's a point on your graph F. As you can see that the graph is drawn as you can see. All right. So the first part says prove that a is equal to 3. Now, usually in an exam kind of situation, what I would normally do is read the given information, then go through and read the questions to make sure I have a good idea of where the question is going. Obviously, being a timed show, we don't have time to go over and read the question twice, but make sure in your exam you answer exactly what the question wants, and that means reading the question possibly more than once sometimes. Okay, so the first one, we've got to prove that a is equal to 3. We've got the function f of x is equal to log x base a. And if I've got a point on the graph, remember that point must satisfy the given function, right? So if f of x is equal to log x base a, and this point, this point here, s, lies on the graph, that means when my x value is a third, my y value is -1. So I can substitute the coordinates of the given point into the x and the y value in my function, and then work out what the value of a is. So I replace f of x with -1, so the function value is -1 when your x value is a third. All right. We need to solve for a. So right now this equation or this function is in the form of a log form, so we need to change it to exponential form. So I'm going to say it's going to be my base, which is a, raised to the power of -1 will give me my number, which is a third. Okay, so we're just going from log form to exponential form there. So a to the -1 is a third, raising both sides to the power of -1 in order to get rid of the -1 on the left-hand side. We get the following. A to the -1 raised to the -1 is just going to give me a to the +1. A third raised to the -1 is the same as saying a third written as a base 3 is 3 to the power -1. We're raising that to the power of -1. When you raise a power to a power, you multiply the powers. So I get a is equal to 3 to the +1. So we've proved the first part, which is a is equal to 3, and that's just 2 marks. Okay, the next one says, write down the equation of h, the inverse of f, in the form y is equal to. So remember, you were given a log graph. Therefore, the inverse graph should be exponential. Let's go through how we would rewrite this. So we know that our log graph is given by y is equal to the equation y is equal to log base 3x. So in order to work out the inverse, remember what you do. The first thing you do is you swap the x and the y values. All right, so I'm going to get x is equal to log y base 3. And then you rewrite this in the form where y is equal to something, which is what the question asked. So y in terms of x. So we're going to change from log form to exponential form, and I will get that y, which is my number, will be equal to the base 3 raised to the power of x. Okay, so what you can see is consistent is that the base of the exponential graph is the same as the base of the log graph, as it should be. So we have an increasing log graph, and our inverse graph would also be an increasing exponential graph. 1.3, if g of x is equal to -x, determine the equation of g. All right, so we are told that g of x is equal to -f of x. Now remember, we've been given the equation of f of x, so it's simply a matter of replacing f of x with the equation log x base 3. You can leave it like that, guys, but this is also equivalent to log a third, base a third of x. So log x base a third. These are equivalent. There's also other equivalent forms of this very same equation. So there are different versions that will be marked correct. Okay, obviously you've got to do it correctly. But this log x base a third would be the function minus f of x. Okay. All right. Or as I said, you can leave it as just negative log x base 3. 1.4. we want to write down the domain of G. Now remember what we've got here. If I had to draw it, we know that we've got the original function f is an increasing log graph. Now, the function negative fx we saw would be a decreasing log graph, because what you've got here, have a look at this. If we had to draw it, it's going to be a graph that looks something like that. Okay, so that's going to be the graph of g of x log x base a third. Okay, and what you can see about the domain of both these graphs is that they are always to the left of the point 0. So they're all the positive values of x. So therefore the domain of g would be, and this is 1.4, either you can say x is greater than 0, or you could write it in interval notation as x is an element from 0 to infinity. Okay, it only takes on the positive values. Note that I used round brackets to show that 0 and infinity are not included. And then lastly, we need to determine the values of x for which f of x is greater than equal to minus 3. Now, if you have a look at your graph, what we're really saying is if we extend this graph, obviously it goes on to negative infinity, right? There's some point at which the y value would be negative 3. So it's going to be some x value, and then the y value is going to be negative 3. So what they're asking you is, for what value of x will this f of x function be greater than or equal to minus 3? So whatever the x value is there, that's what we need to find out, because this graph is then going to be greater than that value for all the values of x to the right of that. Okay, so greater than lying above in terms of the y values, and the x values we're looking for will lie to the right of whatever the x value is that gives me the point minus 3. So the first thing we need to do is we need to find out what that x value is. So in order to do that, I change this and I'll have a look at it from the form of an equality instead of an inequality. So I look for what value of x would give me minus 3. Okay, so what value of x would make the function value minus 3? So I make it equal to minus 3, log x base 3 equal to minus 3, and I solve and change this to an exponential equation, so I get x is equal to 3 to the power negative 3, which gives me 1 over 3 to the power positive 3, which is 1 over 27. So therefore, when x is equal to 1 over 27, you will get a function value of minus 3. So therefore, for all values greater than or equal to 1 over 27 on x, for all x values greater than or equal to 1 over 27, your function value will be greater than or equal to minus 3. And that question, as you can see, 9 marks. If you understand log and exponential functions, you should have had no problem with that question. Remember that those two graphs go together when we're talking about inverses. I think it's time for us to take a quick break before we continue revising functions and inverses. Back after this. Welcome back, everyone. In today's lesson, we are looking at functions and their inverses, and we also remember revising exam type questions because it's never too early to start revising for your final exams. What we saw and what we talked about in the first part of today's lesson, just in case you missed it, functions and inverses account for 23%, roughly 23% of your final exams, and that's just looking at functions and inverses, and we're not really talking about calculus graphs or cubic graphs, which we'll consider under the section of calculus. Okay, so just functions on their own, about 23% of your paper, 23% that you guys need. So make sure you understand how to do your past exam questions by revising past papers. So our next question for today comes from the DBE Maths Paper 1, and this is November 2015, question 6.1. Again, what I'm going to do is I'm going to give you some time to familiarize yourself with the question on the screen. Think about how you would approach it. And if you do have a past paper exam booklet, or if you have access to a computer, you can find this question paper online, and you can then see the memo and all of that online for yourselves. Otherwise, you just follow along with us. Guys, I'm only going to give you 2 minutes to have a look at this question, and then we will go through it. Okay, everyone, so let's have a look at question 2. Remember, as I said to you in our first segment for today, when you're reading through your exam questions, really understand what it is that they are asking you to find by having 2 readings of your questions, just to make sure that you haven't missed anything, okay? Being a timed show, we don't have time to read over things twice, but generally in exams, that would be a good practice to get into. Okay, so we're going to read through this now. We are given that the graph of f of x is defined by minus 2x squared plus 18. So we see that that's going to be a graph with a maximum turning point. And we are also told that g of x, the defining equation, is ax squared plus bx plus c, so that's in standard form. And those are sketched. Points P and Q are the intercepts of f, the x-intercepts of the graph f. Okay, and then you also have that Q and R are the x-intercepts of graph G. T is the y-intercept of both graphs, as you can see. So everything that's stated is actually also shown on your graph. The first question is write down the coordinates of T. So I first look at T and I see that it's a point of intersection of both graphs. It's also the y-intercept of both graphs. How do I find the y-intercept? We say let x equal to 0. Now that means we need an equation to work with. Do we have an equation? Yes, they've given us the defining equation of f of x is minus 2x squared plus 18. So for 2.1, write down the coordinates of t. We know that f of x is defined as minus 2x squared plus 18. And we saw that the point t is the y-intercept. So how do you find your y-intercept? You say let x equal 0. So to find your y-intercept, you let x equal 0, and you will get your function value at 0 is 18. Okay. So therefore, your y-intercept, the coordinates at point T, the x value is 0, and the y value is 18. Okay, and that should hopefully have been an easy 1 mark for all of you. The next one says write down the coordinates of Q. So we go back to the graph and we decide what it is they are asking us to find. Now, if you have a look at the point Q, we see two interesting things happening there. It's a point of intersection of the two graphs. It is also the x-intercept of both graphs, okay? How do you find x-intercept? You use the concept that you've learned and you've been practicing for years now. In order to find your x-intercept, you let the y value or your function value be 0. So because it's an x-intercept on both graphs, I can use the equation I've been given, which is that of f of x. And for 2.2, we're going to say let y equal 0 because now we're looking for the x-intercepts. So I'll get minus 2x squared plus 18 is equal to 0 if I let y equal 0 in f of x. And then solve for x. You can choose to factorize this. I'm just going to take the minus 18 over to the right-hand side, divide both sides by minus 2, and I get x squared is equal to 9. And then what I'm going to do in order to solve for x, I need to square root both sides. So I will get that x is equal to plus or minus 3. So therefore, that tells me that my x-intercepts of the graph f of x is going to be plus 3 at the point Q, and then minus 3 at the point P. Okay. All right, so therefore the coordinates at point Q, remember when they ask you for coordinates, very important guys, and don't lose half a mark here for not writing this as a coordinate. A coordinate is an x and a y value. So we won't just write x is equal to 3, we'll say Q is the point 3, 0. We write it as a coordinate pair. Okay, so that's also an easy 3 marks. The next one, let's read through that. Given that x is equal to 4.5 at point S, so on your graph, let's find point S. And we see that the x value at that point is 4.5, 4,5. They then ask you to determine the coordinates of R, which is the other x-intercept of graph G. Now this one's interesting because what do you have so far? On this graph G, you've got the one x-intercept. Remember, because point Q was a point of intersection of both graphs, the coordinates at Q are 3 and 0, which means you've got the coordinates of one of the x-intercepts of this graph G. Now, this point S is actually at the turning point of this graph G, which means what you've got is you've got your axis of symmetry. So you've got your axis of symmetry, which remember divides your graph into 2 equal parts. So therefore, you know that the axis of symmetry at the turning point is x is equal to 4.5. So if I draw in a line, okay, and this is obviously you don't need to draw this, sorry, that should be much straighter than that. Let's just redo that. So while you don't need to draw this line in for your exam purposes, we need to understand what it is really saying to us here by having this axis of symmetry. Let's see if I can get this straight. If not, we would get the basic idea. So we've got going through this point S, our axis of symmetry, which we said divides the graph into 2, or cuts the graph into 2 equal pieces, which means that every point on the graph is equidistant from the axis of symmetry. Okay, so there are different ways to answer this question. The way I would do it is, I know that at the point Q, my x value is 3. And the point Q and the point R must be equidistant from the axis of symmetry. So if I look at from the point Q to the point S, my distance, the distance from Q to the point S will be 1.5 units. Okay, now because we're talking about the axis of symmetry, it means the distance from S to the point R should also be 1.5 units. Okay, so since these two distances are equal, I can work out what the coordinates at point R are by saying, well, obviously we know it's on the x-axis, so the y value is 0. The x value is going to be your value at point S, which is 4, 5, plus the distance to the point R, which is 1, 5, and 4, 5 plus 1, 5 is going to give you 6 units. So therefore the coordinates at point R are 6 and 0. Okay, now as I said, there's more than one way to do this question. This is the way I would do it. I would look at the axis of symmetry and I would find the distance between the two intercepts and then use that. Okay, if you saw it in a different method, which is also correct, you will get full marks for that. Okay, so the coordinates of R, remember when you list coordinates, we want to have x value followed by y value. R is the point 6, 0. Okay, and now we'll have a look at the next one, the last one for question 2. For those of you who have just joined us, remember this is coming from the DBE Maths Paper 1, November 2015, question 6.1. We are asked for part 2.4 to determine the values of x for which the second derivative of g is positive. Remember what the second derivative tells us, or what it gives us information about when we're talking about graphs. The second derivative tells us about the concavity. Okay, do you remember that from calculus? Concavity. So remember the following points. When your second derivative is equal to 0, that gives us the point of inflection. It tells us that we're looking at the point of inflection of the graph. All right, when your second derivative is negative, which means less than 0, negative, then we are looking at a graph which is concave down. Okay, and then when your second derivative is positive, we have a graph that's concave up. Okay, so those are the different points that we need to remember when we're looking at concavity. Now, the other way that you can think about concavity, because here they're asking you, well, where is the second derivative positive? So they're looking for a graph that's concave up. And the other way you can think about the concavity is if you were to draw tangent lines to the graph, and those tangent lines lie below the graph at all times, that would mean that you are dealing with a graph that is concave up in a specific interval. Okay, so when we're looking at a specific interval, if the tangent lines lie below the graph, then your graph will be concave up. If, however, your tangent lines lie above the graph in a specific interval, then your graph will be concave down. Let me quickly show you what I mean for those of you who may have not heard about concavity referred to in this way. So if I were to now draw a tangent line anywhere on this graph, because we're dealing with a graph that's always facing a specific direction, we're not looking at an interval, we're looking at anywhere on this graph. These tangent lines will always lie below the graph, which means your graph is actually always concave up, which means the graph is actually always going to have a second derivative that is positive. So therefore, for part 2.4, determine the values where the graph is concave up. Well, it always happens. So it would be x is an element from negative infinity to positive infinity if you're using interval notation. Remember, we don't include infinity. Or you could just say x is an element of real numbers. It happens for all values of x. Okay, and as you can see from that last question, nothing is ever taught in maths in isolation. everything comes together in the end. All right, guys, I hope that everything's coming together for you when we're talking about functions and inverses, and you have a much better understanding so far already of how to deal with these types of graphs that we've covered so far. We're going to take a quick break before going into our next exam question. Back after this. Welcome back, everyone. We are now going into our last exam question for today's show. Remember, we're looking at functions and inverses, and we're looking at questions from different past papers. So all of these past papers are available online, of course, or if you've got your past paper exam booklets, you can have a look at them there. The question we're going to look at now comes from your DBE Maths Paper 1, and this is June-July 2015, question 5. This time we are given an exponential graph, and then there's a couple of questions that you need to answer about this exponential graph. Guys, remember, you can find these question papers online, and you'll have the question with you, and also you can find the memo there. But for those of you who've not seen it before, I want to give you a few minutes just to get familiar with the question before we go straight into it. So I'm just going to give you 2 minutes to have a look at this. Right, everyone, let's go straight into this question. I don't want to waste any of your time. Let's go straight into it. We are given that f of x is equal to a quarter raised to the power of x. We straight away should identify this as an exponential graph. All right, we see that our unknown is in the exponent. We are dealing with an exponential graph. The first question, determine the value of f of minus 2. So you're looking for a function value. And the way you would determine a function value is simply replace your x values with the bracket, with the number inside the bracket. So in place of x, I put minus 2. So therefore, my function value, simplifying my exponent, a quarter, is 4 to the power of negative 1. All right, remember, you can rewrite your fraction, a quarter, with the base 4 if we raise it to the power minus 1. And then that's all raised to the power minus 2. And therefore, I get 4 to the power minus 1 times minus 2. When you raise a power to a power, you multiply the powers. So I get 4 squared, which is 16. Okay, so we know that the point minus 2, 16 is actually a point on the graph f of x, and that we'll keep in mind for later on. Okay, so the function value stops there. F of minus 2 is 16. Okay, let's have a look at part 3.2. Question 3.2 says, write down the equation of the inverse of f of x in the form y is equal to. So we're now looking for the inverse graph. Remember, how do we find inverses? We swap the x and the y values and then we solve for y. All right? So applying that to this, we see that initially, and these are things that should be going on in the back of our minds, we are dealing with a decreasing exponential graph. Okay, so therefore its inverse should be a decreasing log graph. How do I find the inverse? F of x, we can replace that with y. So y is equal to 1/4 to the power x is your original function. We then swap the x and the y values. So we get x is going to be equal to 1/4 raised to the power of y. And then we make y the subject of the formula. How do we do that? Well, we simply change from exponential form to log form. So we get that y will be equal to log of x base 1/4. So the base of the log graph and the base of the exponential graph will obviously be the same. Okay. All right, so that was 3.2. That's the inverse graph, and they said leave it in the form y is equal to, so we can leave it as in that form. 3.3. Andrew has no idea how to draw the graph f inverse. So he has no idea how to draw the inverse function. Explain to Andrew how he may use the graph of f to draw the graph of f inverse, so of the inverse graph. So how can you use the original function, which is an exponential function, to draw the inverse function, which is a log function? Now, there's different things you could say in order to answer this question. The one thing you can say is, well, we know that f and f inverse are symmetrical about the line y is equal to x. So therefore, all you would have to do is you would reflect the original graph f of x in the line y is equal to x, and that will give you your inverse function. So reflecting along the line y is equal to x is one way to do it. The other way is, remember your inverse graph, you're going to swap the x and the y values around, which means that your domain of the original becomes the range of the inverse, and then the other way around. The range of the original graph becomes the domain of the inverse graph. Okay, so therefore what you can do is, you know that in your exponential graph your y-intercept is 1, and in your log graph, instead of it now being the y-intercept that is 1, you would get the x-intercept is 1. And then remember, we also have this point on the exponential graph, which is x is minus 2 and y is 16, while on the inverse graph the point 16 minus 2 will be a point on the inverse graph. So you can either use the points and swap them around, or you can simply say, Andrew, you need to reflect this graph in the line y is equal to x. Okay, either way. And then 3.4. Here they say, hence or otherwise sketch the graph of the inverse, clearly indicate all intercepts with the axes. Okay, so depending on which method you use, you might have it drawn slightly different. Well, you might have the points indicated, but you need to indicate all of the intercepts, which is what they said. So remember, we were dealing with a decreasing exponential graph, which means I'm going to have a decreasing log graph as the function of the inverse. So to draw that, it's going to look as follows. Okay, that's going to be your graph f inverse of x. Obviously, that's my y-axis, that's my x-axis. Always label your axes. You can indicate, remember they said indicate your points of intercept, and we know that that's x is 1 and y is 0. We also saw that another point on this graph is when x is 16, y is going to be minus 2, and that's somewhere there on the graph. X is 16 and y is minus 2. Okay, so you can either use the points or you can reflect the graph. You will get exactly the same inverse function. Then quickly we've got to write down the domain of the inverse graph. Well, the domain is your set of x values. As you have a look at your graph that's drawn on screen, you see that we're only dealing with positive x values. So therefore, my domain will be x is greater than 0, or if I'm using interval notation, the other possible accepted answer would be x as an element from 0 to infinity, excluding the endpoints. Okay, and then quickly I want to get to the last question, 3.6. For which values of x will the inverse graph be greater than equal to -2? Now remember, we've already shown on our graph that the point x is 16, y is -2 is a point on the inverse function, right? So therefore, when they're asking me, well, for what values of x will the inverse function be greater than equal to -2, they're talking about this segment of the graph here. All the points that lie to the left of x is equal to 16. So therefore, for x between 16 and 0, we will get that the function will be greater than or equal to -2. Remember, whenever we're talking about inequalities here, we're giving a range of values. So it's an interval of values over which the solution holds true. So it's not a specific point. So it's not x is equal to 16. No, it's an actual interval over which this is true, that this function, the inverse function, will be greater than or equal to -2. If you wanted to, what you could do is, instead of writing it as I did with inequalities, you could show this using interval notation, where we'd say x is an element from 0, not including the 0, up and including the value of 16. So those are two different ways that will get you exactly the same marks in an exam. Okay, all right guys, so remember to practice your past exam papers when you are revising for your final exams. That is so important. And also, as I said at the top of the lesson, one of the main things that you need to do when you start revising is to focus and prioritize the sections that you are weak at. So don't only do the stuff that you're good at, because at the end of the year, as you know, you get examined on everything. So aim to revise everything, but prioritize the sections that you are weak at. Until next time, good luck practicing functions and inverses. Cheers.
Woza Matrix 2021 Catch-Up is brought to you by the Department of Basic Education, NECT, ETDP SETA, SABC, MultiChoice, and DBE TV on OpenView Channel 122 in partnership with